Hello, everyone, and thank you for joining our session. I hope that you had a good first day, a lot of learning at re:Invent. Today, we're going to be talking about two important use cases. So you're going to be learning how OpenSearch can help you with observability and security analytics use cases. My name is Muhammad Ali, and I have with me my colleague, Hajar Bouafif. We're both OpenSearch SA at AWS, which means we help AWS customers build solutions with OpenSearch and, more importantly, get value out of their machine data. So we're going to be discussing that and how OpenSearch helps you with it. And we're going to talk about, give you a couple of reference architectures and a couple of demos. And then we'll give you some resources at the end to get started with these use cases. So IDC predicts that there will be 129 zettabytes of data produced in 2023. That's 129 billion terabytes. That's staggering. And as we are going to adopt generative AI, the machines are going to produce more and more data. In fact, most of the data today is machine generated. And getting value out of this data is challenging. So just to give you perspective of what data are we talking about, we operate application services and APIs all capture their performance and behavioral data in the form of signals like metrics and logs. We have security tools or DevOps tooling that are monitoring our servers and databases, how they're performing. They're monitoring what is the volume of data flowing through the network, who is accessing our application. And then we have IoT devices that are continuously monitoring our business operation environments and reacting to it at the edge, and most importantly, send the data back to the base for analysis. All of this data has immense value and can help you answer many questions. So for example, with the data from application and infrastructure, you could determine if an application is operating as expected or troubleshoot in case of a failure. From our security tooling, we can find out, we can detect whether there is a traffic from a suspicious IP address or someone's trying to access our application from an unknown IP. That could trigger a protective action, such as isolating that server or starting an investigation. And then we have IoT devices. With that, if you were monitoring our factory floors, you're able to answer if your employees are working in a safe environment. So as a builder, how do you go about building machine data insight solutions? So this is what a typical solution would look like. You would collect the data from the source. You're going to put that into a software system that is designed to work with large volume machine data and give you ability to ask questions in the form of insights, both in the form of signals like alert or visual insights to help you understand trends in high velocity time series data. And one such popular software is OpenSearch. And OpenSearch is a pure open source search and analytics suite. It has quickly risen in popularity, and now it's number 4 in the popular search engines. We have over 60 plus partners, and with hundreds of new features released since it's launched. Within this year alone, we have released 8 minor versions, each adding to the core functionality or to the different use cases that you can build with it. All of that comes under Apache v2 license for free. Now, OpenSearch is a distributed system. It runs on many machines. And if you were a company that does not want to manage that software and the infrastructure that runs OpenSearch, you can use it as a managed service And OpenSearch is available as a managed service in many cloud providers. And AWS also offers OpenSearch as a managed service, aptly called Amazon OpenSearch Service, which makes it easy for you to run this distributed technology at scale, with ease, with high reliability, and securely within your AWS account. OpenSearch Service comes out of the box, tested and enabled with these plugins that help you build those use cases like observability, like highly scalable vector search, or security analytics. Then the service also offers integrations with the wider AWS and open source ecosystem to help you build applications quickly. We have features like UltraROM that allows you to store large volume machine data for a longer period of time at a fraction of a cost. So as a developer, when you're building application with OpenSearch, this is how you generally go about it. You identify the infrastructure or the application that will generate your machine data. It could be, logs, metrics, or any other type of signals. Then you send them to OpenSearch in JSON format. OpenSearch talks JSON language. And then OpenSearch indexes all the fields within that JSON document by default for you. And then it gives you the UI and APIs. The UI is called OpenSearch Dashboard that will help you create those insights. It will help you search, analyze, slice, and dice the data. And that is common for all type of use cases. Observability is a very popular use case with OpenSearch. So let's dive into some of the features that OpenSearch offers to make it easy for you to build observability platforms. But before that, let me just define what an observability platform means. Observability platforms help you collect and analyze data from your application and associated infrastructure so that you can understand the internal states and be alerted to in real time if there was any problem. And then it offers you tools to troubleshoot the applications quickly. This helps us in two ways. Your developers are spending less time in troubleshooting and debugging an application, and more time in building those applications and user experiences. That matters to the business more. And second advantage is it helps you minimize the outage window or downtime, because downtimes have consequences. They cost you real money. And do you know that for an average Fortune 1000 company, unplanned downtime costs exceed $1 billion? And then there is significant reputational ramification, which are not measurable. Now, speaking of measuring, how do you know that you have a strong observability strategy in place, and how do you measure your success with that? These are two particular metrics that customers use to measure how they're helping their company reducing those downtime. One is mean time to detect, and the other is mean time to repair. Reducing both of which directly impacts the cost associated with the downtimes. The faster you're going to detect, the faster you're going to repair, the lower the impact of the downtime to your business. And this applies for both applications, like application downtimes, or security breaches. So a strong observability strategy in place for both application and security data would enable you to capture and improve on these metrics. So how do observability platforms achieve these promises? They do so by collecting and processing the signal from your application or security tooling. And as the industry has matured, there has been a general consensus on what signals make a good foundation. Capturing the metrics will help you get alerted if there was a problem in your application. Let's say your user experience was degraded because of higher rate from one of your microservices, and that could intimate you before your users start complaining for it. Then comes the traces. Traces track end-to-end request processing lifecycle. They help you pinpoint the component which is causing the failure or degradation of the functionality. And then when you know which component is causing the failure through traces, logs will surface the events that will help you perform the troubleshooting and identify the root cause. Correlating these three types of signal is critical and will help you minimize the downtime or the impact of the downtime. So essentially what we are saying is this platform will help you reduce time to detect, reduce time to investigate and remediate, so you can build applications that are more available, reliable, and performant. Regardless of whatever technology you're going to use to observe your applications, the reference architecture would remain the same. We have applications that produce these signals, and we need a mechanism to collect these signals from those applications and pass that on to what generally is referred to as buffering layer, which is basically a layer where you're collecting the data and writing and reading that in bulk and writing that to the analytics engine, which in our case will be OpenSearch. And from there, you will start building those rules to create the alerts and detecting the problems and build visualization to perform the analysis. So if you were building similar architecture in AWS, your signal producer could be applications running in any of the compute environment like EC2 or EKS, or even third-party tools. Generally, people use agents-based collection or collectors, which can be open source or AWS native. Many of you are operating polyglot architecture, which means there are different languages. So it becomes a challenge to standardize the way you're going to collect these signals, which is where OpenTelemetry comes into the picture. It is a very popular observability framework that offers vendor-agnostic SDKs and libraries to instrument the applications. It supports many languages and collects logs, trace, and metrics data. It is fast becoming a de facto standard, which is why the monitoring and observability vendors are offering compatibility. So using such standard, common standard, or tools allow you to build an architecture where you can replace the backend observability engine without impacting the large landscape of your application that is already instrumented. Generally, from the collection, you would send these signals to, as I said, a buffering layer. For most of the log analytics use cases, we've seen S3 is sufficient for collecting the logs as a buffering. But if you have a requirement for low latency, then you can use some sort of streaming-based buffering, and that's where OpenSearch ingestion service comes into the picture. OpenSearch ingestion service can read from S3, and also you can point your OpenTelemetry collector directly to it. So it basically parses the data, enriches it, and writes that to OpenSearch. Now, for those who are not familiar with OpenSearch ingestion service, it is a fully managed service that delivers real-time log, trace, and metrics data to Amazon OpenSearch service domains, or the clusters, or OpenSearch serverless collections. It is essentially a managed service for open source data prepper. If you're not familiar with data prepper, it is a community-driven open source project under the umbrella of OpenSearch. It allows you to filter, transform, enrich the data, and deliver to OpenSearch service clusters or OpenSearch clusters. And it's part of, as I said, the open source project. When you use OpenSearch ingestion service, it offers AWS private link support, which means the data remains within that secure network and in your VPC. Under the hood, the data prepper works based on what is called pipelines. Now, pipelines have source, processor, and sinks. Source is where the pipeline is either going to read the data or receive the data from, let's say, OpenTelemetry collector. Then we have, and passes this on to processor, which will filter, enrich, and convert the data into the format that can be loaded into OpenSearch. Then you have sync, where you have OpenSearch and Amazon S3 as a supported sync. So pipeline is generally defined, or is defined in YAML format. We have section for source, processor, and sync in there. On the screen, you see a pipeline where the source is HTTP. This would create an HTTP endpoint with that resource path. And it will collect the data and pass that on to the processor. And in the processor, we are asking the ingestion service to use common Apache log pattern to parse the data and identify or create those fields in the JSON document. And then in the sync, we're saying it to write it to a specific domain. This is where we provide the endpoint for the domain and the index name where you need to write the data to. Now, many of you are operating applications in AWS. You would be using AWS services or common open source applications like Apache log server, web servers. Therefore, we have created a bunch of blueprints that you can use as a starting template for collecting these common signals. And you can basically select the template and it will write that YAML format for you. And then you just plug in your specific details of your endpoints on your servers. Finally, the analytics engine in our use case or in our architecture is OpenSearch. And OpenSearch dashboard is the visualization tool, which is the user interface that comes bundled with OpenSearch service. The important thing here to note is the pipelines work with any type of signals you can have, or any type of log data, or metrics data, or trace data. From application or security tools, getting your data in OpenSearch will follow the similar pattern. So it works both for security and applications. Now on the screen, there's a QR code of a solution that some of the AWS assays have put together to create the centralized logging solution for you. Now you would be able to write metrics to OpenSearch, and you can use OpenSearch for that. However, we believe that you should use a purpose-built tool for everything, which is why Amazon Managed Service for Prometheus comes into the picture, which is a managed service for Prometheus, which is designed to store large volume metric data. And Grafana is the dashboard tool that works very closely with Prometheus. In fact, open source OpenSearch dashboard also can surface or query the data from Prometheus. So this completes our architecture, and in fact, this is exactly what the architecture you will see in our demo today. So let's jump into the demo. So for this demo, I have prepared an e-commerce application that runs in EKS cluster. So we have 6 containers that are representing different microservices instrumented with OpenTelemetry. So we're collecting traces and metrics through OpenTelemetry and logs through Fluentbit, and then passing it on to the OpenTelemetry collector. The metrics are written to Amazon Managed Prometheus, and logs and traces are forwarded to the ingestion service, which writes that data to OpenSearch service and OpenSearch dashboard. So we'll use OpenSearch dashboard for investigation, and Grafana and OpenSearch dashboard for alerting for our use case. Now my application is a simple shopping cart application. You select the products and you go through the checkout process, through the whole the shopping cart process. Now for this application, I've planted a bug in there. So when we are going to interact with it, there will be errors in there. Now let's set up our observability dashboard first. For that, I logged into OpenSearch dashboard and I go to applications, and we're going to compose an application. What does that mean? It means we're going to tell OpenSearch what services from that trace data make up my application, so I can hand it over to a single team that can monitor this, or they can use this dashboard to observe the application. We define which log source that is relevant for this particular application. So here we're providing the source, and we're selecting the services. And this data is already collected from OpenTelemetry sitting in OpenSearch, and that's how it knows the name of the services. So as soon as we select all the services, it's going to show us how they're interacting with this application composition map. So our application composition is ready, so we're going to create that. And we're going to go back to our, we'll go to Manage Grafana to show you the dashboard part on the metrics. So here I've created a dashboard that monitors the CPU, memory, and disk utilization of the containers that are running in the EKS. And most importantly, there's this panel for this demo is monitoring two of the service, payments and order. And I've created an alerting rule here on the metrics, on the CPU utilization metrics. So the rules will say if the CPU utilization goes above certain level and stays there for 30 seconds, alert me in my, to my SRE channel or Slack channel in there. So that's one place where we can monitor, which is the metrics. The other bit is log signals. So for logs, we have alerting plugin in OpenSearch that allows you to create monitors. Here, we're creating a monitor that looks into sample application log data and finds if there is an error in any log line for X number of errors in last 2 minutes, it sends a message to the SRE channel again, the same channel which is built for the SRE team. Here we provide all the details, and it is configured with the webhook. So I'll create the traffic, which is going to start putting those errors because there's a bug in the application, and then we get an error, an alert. This is from dashboard. For this demo, I'll just keep on pushing the traffic, so it actually goes beyond that, beyond the CPU level, goes higher, and Grafana also sends us the alert. So here we'll see CPU goes higher than that level. It will show us as a yellow dotted line, and then it will breach that threshold of 30 seconds, and we'll get an alert in the Slack channel. Now, within the alert, the good practice is to put the link of the dashboard where they can start investigating. So my team will click this link and jump straight into the observability dashboard that we set it up. Here we'll see all the traces, all the functionality like checkout and pay order that are going in there. In application composition map, I can see the payment is causing a lot of error. But with trace group, we see checkout has 100% error. So we'll drill down into it. We'll see that how the client checkout trace group has a problem. We are drilling down to individual user requests, which is the traces. Now, we can click any of these traces, and it will show us how these services are calling each other, and you can see the whole stack of services. And you can also see where the errors are coming in there. So we have a good idea about where the error is coming from, which is the payment service. You can see it in different ways, and you can go to the details of each trace. Now let's correlate it with the logs. So we'll put it here in the language called PPL. PPL allows you to query data easily from OpenSearch, following pipe processing sort of format. So here we put the trace ID, it surfaced the event in the log, which potentially tells us there was a problem. Now to investigate this thing, I want to see the events that happened before and after this error. So as you can see what has happened after and what has happened before this event. And if there was anything that of interest, we can find that out there. What caused that problem. Now my error itself has a lot of details. It says that payment service.python on line 77 has an error called checkout operation fail. Now this is how we troubleshoot it and came to the root cause. Because the bug is planted by me through changing a certain variable in the code, I should be able to fix this problem. Here I fixed the problem. And the other important thing is when you're going to fix a bug, you need to see the feedback whether this has resolved the problem. So as soon as I rebuild and deploy my payment service again and send some traffic, the error rate should start going down. So we'll generate the traffic and see the dashboard again. You can see 87.5, which is basically lower than 100. I'll continue to generate the traffic for the error rates to go down. So we go down to 70, and let's see last few minutes of data and see if this is all resolved. And I'll just check last 10 minutes in that moment. And this tells me that everything's fixed. I can look at the error rate again. There's no dot which is showing the error are there. So we were able to detect, investigate, resolve the problem, and see the feedback of it. Now, that was the out-of-the-box demo or out-of-the-box user experience that comes for observability data. Now, you may be wondering, what is required to visualize my custom logs or the common services log that from AWS that we use? We have in OpenSearch project what is called OpenSearch integration, which is the collection of common visualization for assets for popular sources. So with one click of a button, if you're using web application firewall, it can create the dashboard for you. Now, good thing is because these are assets, you can create a comprehensive dashboard that looks at all your layers of application. Now, it works for both application logs or security logs. However, for security logs, you might want to do something a bit more. So for that, I'm going to call my colleague, Hajar, who is going to take you through the features that are in OpenSearch that we offer for security analytics.
Thank you, Ali. Hi, everyone again. So far, you learned how to analyze logs, traces, and metrics using observability features in OpenSearch service. I want to focus on one particular pillar of observability, which is log analytics, and more specifically, security log analytics. So in this section, we'll go through why this should matter to you and the different strategies that you can leverage using OpenSearch service to build your security analytics log solutions. So currently, at this point, we witness an increase in the frequency of the security issues or attacks. And we also witness an increase in the sophistication and complexity of the security issues. This is due to multiple factors, but one of them is that the systems themselves are getting more complex in nature, right? So are the security issues, so it follows the state of the systems. Another element to why security issues are getting more complex to detect or investigate, they are powered by artificial intelligence now. And AI is ubiquitous, is integrating all domains in our lives, from self-driving cars to healthcare diagnosis systems, et cetera, which pushes governments actually to build new legislations to make these self-driving cars safer and protect your privacy data. So this means that your teams, DevOps teams across the organization should be aware of this and understand what is coming in terms of legislations to keep up with it. Also, when we talk about securing your system, that also means that you are securing the access of your customers, that you are making your application trustworthy. Customers now are more aware of the privacy issues concerns. So when you protect your system, you're actually protecting your business also. This journey ahead of cybersecurity raises many challenges for your teams, not only security teams, but also DevOps teams, developers teams that should be aware of this current state of or current landscape of security, and they should be able to handle the challenges that come with the current landscape. First, your organization, your teams should be able to collect and store this high volume of data that we are generating in a daily basis. They should also be able to integrate new coming data from different sources. Security log data comes from cloud, from on-premises applications, from third-party providers, et cetera. So you should be able to power your teams to easily integrate these new sources of data and be able to analyze it. All these applications are churning out logs of different formats or different languages, if we want to call it that way. So this challenge brings your team to generate or create hundreds of queries to be able to analyze these log data and correlate the log data to understand the context of the security issue, for example, or the context of even on observability, the context of a system issue, etc. You should also be able to leverage the community knowledge. This is very important currently. We need to grow all together. So leverage as much as possible the open standards that are available in the community. And the cyber security community is very active. And we'll discuss in a few slides what are the common standards that you should be aware of to handle these challenges. And this will also help your team to lower the barrier of entry for them, whether DevOps, engineering, developers, and security teams. For this, I would like to share a few strategies on how to handle these challenges. First strategy, I would like to introduce security analytics plugin with Amazon OpenSearch service. So it is bundled within the OpenSearch managed service. And it offers features and tools to be able to detect, investigate, and resolve issues. Same for observability. So Ali earlier mentioned about two metrics, right, that you need to focus on. MTTD, mean time to detect, MTTR, mean time to resolve. But there is another metric that you should be able to reduce across time for security analytics use cases, which is MTTC, the mean time to complete, basically the time that your team spans to complete an investigation and resolve a security issue. The security analytics plugin also offers a couple of features. More of them I will show later. But the first one is that you will be able to use out of the box more than 10 log types. This means that the security analytics plugin will automatically offer mapping for DNS logs, for example, or system logs, Windows logs, etc. And you will be able to use out of the box more than 2,200 Sigma rules. Sigma rules are based on an open source project, which is called Sigma. And it offers you a wide coverage of threats that are happening across systems and industries in the cybersecurity community. So it simplifies the process of creating security rules, and it also will help you to share the security rules that you build in your organization with other organizations and vice versa. So you take from the community and you give back to the community. The second standard that I would like to share with you today is OCSF, Open Cybersecurity Schema Framework. It is an open standard as well. And it provides you standards for log formatting. So we talked about DNS logs, system logs, etc. So it offers you a way to map the data or build formatting of the data. How does that work? OCSF puts the log data in terms of categories. So you have OCSF categories. Like, for example, network activity category, findings, identity and access management category, etc. And under each category, you have OCSF classes, right? So you have, for example, RDP activity class, SSH class, under network activity category. We have over 145 partners that are working on the project, including, of course, AWS, and also partners like Splunk, Cloudflare, etc. So coming back to the available features within Security Analytics plugin, first, you'll be able to create the detector. The detector is the tool or the mechanism for you to set up what are the rules that you would like to analyze within your system, what are the threats that you would like to analyze. And you can leverage out of the box also MITRE ATT&CK knowledge base. This is a global knowledge base of advisory tactics, basically, in cybersecurity. It gives you an understanding what are the different threats, and also an understanding of how to mitigate these threats, basically. I will show you in the demo later how to leverage or use a MITRE ATT&CK in your investigations. Then you will be able to use the Sigma rules, like over 2,200 Sigma rules that I mentioned, or you can also build your own rules in the security analytics plugin. You will be able to leverage the out-of-the-box log types, and we also added the support of building custom log types recently. Within the same plugin, you will be able to create alerts. So what is the frequency of alerts that you would like to receive, in which channel, email, SNS notification, link it to PagerDuty, for example, or Chime, Slack, etc. Whenever there is a threat or, let's say, potential issue in your system, that is called finding. Okay, so when a detector completes an execution, it will generate a finding for you. We'll show you in the demo how does that work. And once the findings are generated, the plugin will be able to give you a visualization of the relationship or the correlation between the different findings in the system. And this is very important in security analytics investigations, because you might have network security logs that are coming in, but you should be able to correlate these security network data with application security logs as well, in terms of notification and etc. Now, how the detection workflow looks like. First, of course, you need to identify and index the logs data that is coming from your security tools, systems, network, etc. You will build the detector, in which you will define the security rules that you would like to use, configure the alerting mechanism, and then use the finding to investigate, to detect, of course, and investigate the security issues. This is how the correlation engine looks like. So in this screen, you see OpenSearch dashboard, and here there is a graph of one finding, and then the correlation between the other three findings. The red color means that the severity of that finding is high, right? The green color means that the severity is low. However, pay attention, that might be a risk that you should be aware of in your system and probably worth checking as well. In the right-hand side, you see the correlation cards here. So in correlation cards, you will have information about each finding, what is the detector that generated that finding, and the rules, the log type, sources, etc. With no further ado, let's go to the demo. So here, let's imagine you are a DevOps engineer or security engineer. You received an alert via email, for example. And you will connect to OpenSearch dashboard to investigate that issue. First, you need to go to OpenSearch dashboards. Under OpenSearch plugins, you select the security analytics plugin. Here you have different tabs. So you have overview, findings, the list of findings that are generated in the system, alerts, detectors, and the correlations. So in terms of investigation, we stick with the overview. And here I can see that we have total of 97 findings that have been generated in a couple of days, with total 4 active alerts. Within this histogram, you can also group by or display the number of findings per log type as well. So here we change the group by to log type. Okay. back to the original one, and here you can hover over and you can see the number of alerts per day and the number of findings. Under the histogram, you will be able to see more details about the findings. So here, the recent alerts, the alert severity, and then the recent findings that are generated in your system with the rule name that triggered that finding, the severity, and the name of the detector. Now, this graph is important. So this shows us, like, for example, we have a high percentage of findings probably. So here, 68% of findings are related to publicly accessible RDP service, right? So this raises a great point for you, saying, hey, there is a lot of findings generated here. We need to check what is happening in the system. And then you have the list of detectors that are available on your system as well. So back to the investigation, we'll move to the findings where we need to investigate the publicly accessible RDP service and understand the context of it, understand what is happening through the logs that are received from different applications. And here I can see all the findings or the details related to these findings, right? So I can see the time where the finding has been triggered, the finding ID, the rule name, the threat detector that generated the finding, log types, rule severity, of course, and actions. Okay, so we'll check for the publicly accessible RDP service. So we can see the rule severity is high, so we definitely need to check this out. For that, I will go under the actions, and I will view the details about this issue. So here, the finding details, you see the rule details, right? So in this rule details called publicly accessible RDP service, I can have a description, but also a tag about that specific attack. And this is where we will leverage the MITRE ATT&CK knowledge database. I can have more details in OpenSearch dashboard about this attack, this rule, who created this rule, the author, the source, and here I click on that tag, and it will redirect me to the MITRE ATT&CK public website to understand this kind of issue and what are the possible mitigation solutions that you can leverage. Once I have more information about this rule, how I can resolve the issue, I go back to OpenSearch dashboards. Here you can also have more information about the false positive cases, the rule status, etc. So these details are important in your investigation to be aware of outliers, etc. Now, in terms of investigation, it's important also to understand what's happened before and after that event. And this is where we check the surrounding documents. And here, OpenSearch dashboard shows me 5 events that happened prior to that event. So probably worth also checking if there is anything unusual there. Right. So now, under the finding details as well, I can see correlations here. I can see 12 correlations, right? So let's jump into that. And here, I don't need the details, so I will just jump directly to the correlation graph to have a visual understanding of the system status. Here, we have a graph that is generated for us. And if I go scroll to the finding, the middle, so this is our finding, publicly accessible RDP service. Let's check the correlation with highest severity. We have sign-in failure, bad password thresholds. This means, first of all, you have a publicly accessible RDP service that is open to the public. Second, you have someone that is trying to access your application, and they are raising this issue of wrong password. So you definitely need to fix the publicly accessible RDP service, but you also you need to check who is trying to access your application and fix that issue at the same time. And here you can also have an understanding of other rules that are generated and other risks or potential risks that are correlated to this specific issue. And talking about the cards, so here in the cards there, you can see all the details about all the findings that are correlated to the publicly accessible RDP service. Right. So I went quickly there. So now you understand how to use security analytics plugin to detect, investigate, and resolve issues. Let's take a use case where your security team needs to index new type of data coming from in-premise environment, for example, and you don't want to overwhelm or wait for engineering team to build the ingestion pipeline. This happens all the time, right? So how to make it easier for your security teams or SecOps teams, etc., to be less dependent on the engineering team? This is where I would like to introduce Amazon Security Lake. If you are not familiar with the service, this is a managed service that we released at re:Invent last year. And it automatically centralized security log data into a purpose-built lake, which is based on Amazon S3. It adopted OCSF format standard that we discussed about earlier. So it automatically transforms the log data that is coming from cloud, AWS cloud, other cloud provider, in-premise, third-party tools into OCSF format and store it into also Parquet format in S3 for best performance, etc. And on top of that, you can leverage or you can use any analytics solution. So in this use case, we use Amazon OpenSearch service to read from security lake data, analyze the data. But you can also use Amazon Athena, for example. You can use Amazon SageMaker to train your models and understand the trends in your security log data. So how Security Lake integrates to the pipeline, right? So we pull back the reference architecture that Ali shared with you before. The same pipeline for observability applies to security use cases because security analytics, security log analytics is part of observability as a whole. Within this pipeline, we will focus on the collection and buffering, and this is where we will replace it by Amazon Security Lake. Security Lake will automatically receive the logs from your sources, transform it into OCSF and Parquet, stored in S3 for you. And since we are using Amazon OpenSearch service, it uses a data access pattern or subscription model with Security Lake. And this use case, Security Lake will automatically create a simple queue service for you to send a notification to OpenSearch ingestion service wherever there is a new document that is available in the Security Lake. So OpenSearch ingestion service will receive notification, read the data from Amazon S3, and store it into OpenSearch service, where you can use OpenSearch dashboard to use security analytics plugin to build your investigation use case, or simply to analyze the data, use PPL, and build dashboards. Now, this is how the pipeline looks like right now. Let's move to the transformation. The good news for your team, for your organization, is that OpenSearch ingestion service offers out-of-the-box blueprints to read from Security Lake and index into OpenSearch. And this is how the pipeline looks like. Okay? We'll go into it part by part. First part, which is source. In source, you will just need to update the SQS main queue URL that is automatically created by Security Lake in your account. You will update the AWS region. You will update the STS role ARN with the ingestion role. The ingestion role should have permission or allow OpenSearch ingestion service to read the notification, delete notification, and also read from Amazon S3. The second part is processor. So the default processing here is simple as putting the OCSF class name into lowercase, replace the white spaces, and deleting some events coming from S3. But you can also, of course, customize the processing based on your use case requirements. Now moving to the sink, and within the sink, you will just update the host that will receive the log data. Here you will put OpenSearch endpoint. You will also, you need to put or specify the pipeline role that will allow OpenSearch ingestion service to write in OpenSearch service. And then you will specify the index that will receive this data. In the blueprint, we follow a naming pattern where we put the OCSF category, OCSF class, and also the ingestion date. You can follow the same pattern that we recommend, or you can, if you have other requirements in your organization, of course, you can update and change the blueprints. So looking at the different strategy that we shared with you, whether for observability or security analytics use cases, we have different benefits that we should look at. And this is where you also should look when you build your architecture, basically for observability and security analytics. First, the architecture diagram and the solution that we shared are extendable in the sense that OpenSearch service you've seen, whether for observability, it can integrate with Prometheus, with the Grafana. With security analytics solutions, you can also integrate with Amazon Security Lake. It integrates with OpenSearch ingestion service. So here you need to think about a solution, not specifically a service, and also understand how you can extend that solution in order to handle the use case and evolution of your use case. Observability features and security analytics also will help your team to analyze real-time data and also analyze historical data if needed. And it offers you the features, the toolings to help your team, to power your team, to quickly analyze any issue, to quickly investigate and resolve, to reduce downtime and reduce the security impact on your business. And in terms of cost, of course, which is one of the main best practices or like pillars that you should follow in building your architecture, think about how I can build the optimized architecture while reducing cost. And here, OpenSearch ingestion service offers different options for this. One of them is to leverage this storage tiering, hot, ultra warm, and cold. So you can store more data for longer time with less cost. Three main takeaways that I would like to share with you tonight. First, think about centralizing the observability and security data whenever possible. This will help you to build the contextualization of your issues with the health and understand the health of your system overall, whether for observability, application observability, or security analytics. Leverage the open standards. It is important to work as a community. Whether you learn from it to, for example, security analytics, you use the Sigma rules and you give back or share back to the community. This will help your team to ramp up quickly, actually, on the current state or the current landscape in security analytics and observability. And third, think about using managed service, right? So in this use case, you leverage OpenSearch for observability and security analytics to allow your team to focus on what they should be focusing on, not spending their time on infrastructure management, software updates, or patches, etc. These are some resources that we'd like to share with you tonight. So if you're not familiar with OpenSearch service, the first QR code, it will direct you to the official documentation. We also can have a look at the best practices, the reference architecture, the new releases in OpenSearch blog post. Last QR code is the centralized logging with OpenSearch solution that will help your organization to quickly start with log analytics use cases. Big thank you, everyone. Big thanks from me. Big thanks for Ali. I'll give it to you. Take it from here.
Thank you, everyone. And for those data heroes, this QR code points to other sessions that you can attend to learn more about AWS data. Again, thank you for attending our session. And there's a mobile application, there's a survey available in your mobile application, so please use that, provide us the feedback, and let us know how we can improve. We hope that you enjoyed our session, and have a good rest of the evening.